Here is example 3. In this example, he wants us to find the voltage across capacitor V0 of t at t equal to 0 plus. At t equal to 0, we are turning off, turning off the switch. So switch is going to be open. So first thing we need to do in this type of examples, we need to find the initial conditions. Okay, what is going on at t equal to 0 minus. So before opening the switch, what is going on? Those are called initial conditions. So we're trying to find the initial conditions here. Since it's a DC source, I can see it's a 20 volts DC source. Inductor act like a short circuit, capacitor act like a open circuit. So initial condition. Okay, so that's what I did. Here is a short circuit and open circuit. So the current passing through this is 20 divided by 5, because there won't be any current passing through this because we have a 0 ohm resistor in parallel with 1 ohm resistor. So I must be 4 amperes. This is I0 minus. That's the initial current passing through that inductor. What is the voltage drop across the capacitor? Initial voltage drop. So the short circuit is parallel with open circuit, so voltage drop across short circuit is 0. So here voltage drop across this must be 0. So V0 minus is 0. Now convert the given circuit into S domain after t equal to 0 plus. So here I'm taking t equal to 0 plus. So now when I convert this, here is the inductor is going to be S over 4. Actually it's 0.25 S. So 0.25 S is nothing but S over 4, 1 over S, L I0. That's the voltage across the initial voltage across the inductor. Okay, and 1 ohm resistor, 1 over S. So after simplifying this, this is how the circuit is going to be look like. Our goal is finding V0 of S. So supply voltage is 1 volt. Now this is S over 4. So all I need to do is use the voltage division rule. So what I did, I found, let me take this as Zx. So Zx is right here. Okay, so I found the Zx. Now I use the voltage division rule. Voltage division rule is nothing but total voltage multiplied by same impedance divided by total impedance. So this is look like S over 4, whatever this Zx, and I have minus and plus, that's 1 volt. So Vx or V0 right here, V0 equal to total voltage, which is -1, because I have plus here minus there, so this must be -1 over 1 over S over 1 over S plus 1, 1 over S plus 1 plus S over 4. So basically I did the voltage division rule here. Okay, so don't forget I have -1 here, so that's negative, that's negative, that's negative, that's negative, negative there. Okay, so V0, I ended up with V0 equal to -4 over S square plus S plus 4. Now I need to convert this into time domain. So when I convert this into time domain, V0 of t, use the Laplace transform table. By using the Laplace transform table, find out which one is similar to this in S domain. So here if you look into the same 19th one in the Laplace transform table, I have e to the power of at sine bt equal to b over s minus a whole square plus b square. Okay, so I'm going to write it down this in that format. Okay, once I convert that into in that format, I end up with v0 of t equal to -16 by 15 e to the power of minus half t sine 15 by 40. Okay, now here is the next example. Here these two are DC sources. One is 2 ampere source, another one is 10 volt source. So the initial condition, switch is at t equal to 0 minus, switch is connected to A, and at t equal to 0 plus, switch is moved to B. Okay, so first we're going to find initial condition. Okay, and our goal is finding voltage drop across the capacitor. So first find the initial condition. So initial condition, I have 10 volt there. So what is the voltage drop across the capacitor? Capacitor must be 10 volts. Initial voltage across the capacitor must be 10 volts. Once we find the initial conditions, always convert the circuit into S domain. So now I converted the circuit into S domain. So 2 over S, that's 1 ohm. Resistance is not going to change. 1 over CS and V naught over S. So V naught is 10 volt, 10 divided by S. 1 over CS is nothing but 2 over S, 1 ohm. Okay. Now our goal is finding V of S. V of S is nothing but I chose that as Vx. So Vx is same as V of S, which is IR times 1. To find IR, apply KCL at Vx, or to find, anyway, our goal is finding Vx. To find, I don't need this, Vx equal to Vs, apply KCL at Vx. Okay, so I'm applying KCL at Vx. So 2 over S is coming in, IR is going out, IC is going out. So 2 over S equal to Vx over 1 plus Vx minus the voltage at this point, I have to ground this, is 10 over S. Vx minus 10 over S over 2 over S. So after simplifying this, I ended up with 2 over S equal to Vx plus Sx minus 10 over 2. So after simplifying this, I end up with Vx equal to 10s plus 4 over S times S plus 2. So I'm going to separate this into two terms. I mean, the order of the denominator is 2, so I'll end up with 2 terms. So A over S plus B over S plus 2. Now I found the A value, which is 2, by using substitution method. B value, which is 8. Okay, so Vx equal to Vs equal to 2 over S plus 8 over S plus 2. V of t equal to 2 plus 8 times e to the power of minus 2t ut by using the Laplace transform table. Thank you.